So in the last session, just we started about re-entrant lock. Regarding, lock interface we covered. java.util.concurrent.locks package. Regarding, so the main problem what we faced, the main problem what we faced with the synchronizer keyword is, so performance wise problem. Next, and after the deadlock problem is there, like there are several API support is not there, like there are several problems we faced. To overcome these problems, so java.util.concurrent.locks concept came in the 1.5 version. In the, so the first interface we covered already. What is that interface? Lock interface, right? Sir, can you tell how many methods are there in the lock interface? Okay, 5 methods. What is the first one? Can you please get lock? Lock is the method. Can you please just try for lock? Can you please try for lock? Third one, lock, try lock. Next, and after the try lock with a time period also. Okay. Fourth one, lock interruptably. Okay. Fifth one is nothing but unlock. Fifth one itself is unlock. Regarding these things, what you people should aware clearly, right? Okay. So lock, try lock. Next, and after that try lock with the time period, lock interruptably. Next, and after that unlock. That's all. So these things by default you people should aware clearly, right? Now for this, the next one, lock. The next class, implementation class is nothing but re-entrant lock. Re-entrant lock is implementation class of lock interface, because with interface we can't do anything. Compulsory implementation class must be required. Re-entrant lock is the implementation class of what? Lock interface, right? Now it is the direct child class of what? Object. Are you getting? Next, why the word re-entrant? Re-entrant. What is the meaning of re-entrant? So again and again, correct, right? Re-entrant. Can you please get once again? Again and again is nothing but re-entrant. There is a clear meaning is there. Why the word re-entrant? Just namesake by default they added this one. No, there is a clear reason is there why the word re-entrant lock. That part I will explain. First add. Keep supporting re-entrant lock. It is the implementation class of. It is the implementation class of lock interface. It is the implementation class of lock interface. It is the implementation class of lock interface. And it is the implementation class of lock interface, and it is the direct child class of object. And it is the direct child class of object. And it is the direct child class of object. Direct child class of object. Okay, direct child class of object. Next, do you know here re-entrant means, sir, here just observe this one. Suppose I have one lock object is there. Assume re-entrant lock L is equal to new re-entrant lock. Sir, I got lock object. Are you getting? Re-entrant lock L is equal to new re-entrant lock. I got lock object. Now my target is L dot. Here just I am taking lock. L dot lock. Sir, I got the lock. Are you getting? L dot lock. Sir, I got the lock. Okay. So do you know this line executed by main thread? Assume that. Okay, main thread. So main thread got the lock. Hold this lock. Okay. How many holes are there for the main thread on this lock object? Is nothing but one hold, because it requested for the lock how many times? Only one time. For every thread internally, JVM is going to maintain hold count. Are you getting? Hold count? Pass for this lock main thread, how many holes it has is nothing but, do you know, its value by default is nothing but what? 1. Earlier 0, now I requested, that's why L dot lock is nothing but m. On the same lock, again main thread can request, boss, I want another hold, because I want more strong, another hold like. Now L dot lock. Are you getting? Now hold count will become what? 2. Are you getting? Because this line is also executed by main thread only. Next, L dot lock. L dot lock. Sir, now 3 holes. Are you getting? L dot lock, L dot lock, L dot lock, like 3 holes by default we have. I hope is clear. Now L dot unlock. L dot unlock. Main thread is going to call unlock, boss. Can you please decrement my hold count? Whenever we are calling L dot unlock, don't feel immediately thread releases the lock. Are you getting? Current thread has how many holes? 3 holes, right? Whenever we are calling unlock, reverse operation. Now hold count will become what? 2. Okay. But lock won't be released. Next, L dot unlock. Once again. Now it will become what? 1. Next, L dot unlock. L dot unlock. Now its value will become what? 0. Are you getting? Whenever hold count reaches 0, now the thread releases the lock. Are you getting? Same thread can hold multiple holds on the same lock object. Are you getting, right? So that's why re-entrant. It's always requesting again. This type of facility is there. That's why this one is by default considered as what? Re-entrant lock. Are you getting, right? More strongness, boss. So I have the lock. How many holes you have on this lock object? Sir, 4, 5, 6 is nothing but more strongness. Yes, boss. Even one time unlock, no effect because it won't release that lock. Are you able to understand? So that's why the word re-entrant. The same thread again and again can enter or can acquire this lock object once again. Is it clear for all of you? That's why the word re-entrant. Okay, at this point. And re-entrant means a thread can acquire. Re-entrant means a thread can acquire same lock multiple times. A thread can acquire same lock multiple times without any issue. Re-entrant means a thread can acquire same lock multiple times without any issue. Without any issue. Next up, internally re-entrant lock increments. Threads personal count. Internally re-entrant lock increments threads personal count whenever we call lock method. Threads personal count whenever we call lock method. And decrements counter, and decrements count value, and decrements count value whenever thread calls unlock method. And lock will be released. Whenever count reaches 0. And the lock will be released whenever count reaches 0. That's all. Are you getting the point, right? So what is the meaning of re-entrant? Now the terminology is very, very clear for you people, right? Okay. So hold the count like this. So clear for all of you, right? Re-entrant lock L is equal to new re-entrant lock like this. Okay. Next, keep subheading constructors. Okay. Yeah, first one. Re-entrant lock L is equal to new re-entrant lock. L is equal to new re-entrant lock. Okay. Yeah, creates an instance of re-entrant lock. Creates an instance of re-entrant lock. Okay, is the first one, right? Now second one, Here re-entrant lock L is equal to new re-entrant lock. Re-entrant lock L is equal to new re-entrant lock. Okay, Boolean, have you observed Boolean fairness? Boolean fairness is nothing but like Boolean fairness. Do you know here just a few fairness? Okay, in the last session somewhere I used this word was be a bit fair, don't do the fraud, don't be biased. Is nothing but, are you getting? Somewhere we may use the word whenever there are some games going on. Is nothing but like don't be biased. Are you getting? Biased, unbiased. What is the meaning of biased? Means fraud? No, na? Reverse? Huh? Biased, unbiased. Next and after that something, don't do the fraud. Be a bit fair, man. Why? Like we are using, right? So that's what fairness. Fairness is nothing but don't feel fair and lovely. Okay, no, it is not related to that fairness. So be a bit fair attitude. Be a bit fair. Okay. So don't be a bit fair is nothing but that thing is by default considered as what? Fairness, right? Okay. If I kept fairness as a true, what will happen? So I'm keeping, because Boolean the allowed values are either true or false. If I'm keeping fairness as a true, what will happen? Very simple, is nothing but fairness as a true. Very simple, longest waiting thread will get the chance. Suppose if multiple people are waiting, then who has to get the chance? Are you getting? Who has to get the chance? Actually, strictly speaking, which one is the good? Which one is nothing but fair? Which one is the fair? Boss, if opportunity is there, longest waiting person has to get the chance. Is nothing but like if lock is available, then longest waiting thread will get the chance. Are you able to understand, right? This is what is the fairness. So what is the default value? Sir, I am not setting anything in the first case. Then what is the default value? Default value is false. We don't know which thread is going to get in the chance. Boss, longest waiting thread should get the chance. Is nothing but compulsory. You have to set fairness policy as what? True. Are you able to understand, right? Okay, add. Take the second constructor. Add re-entrant lock L is equal to new re-entrant lock of Boolean fairness. Boolean fairness. Boolean fairness creates a re-entrant lock. Creates a re-entrant lock with the given fairness policy. Creates a re-entrant lock with the given fairness policy. With the given fairness policy. With the given fairness policy. Given fairness policy. Next up. Given fairness policy. Next up. If the fairness is true, then longest waiting thread. If fairness is true, then longest waiting thread can acquire the lock. Longest waiting thread can acquire the lock if it is available. Longest waiting thread can get the lock if it is available. That is it follows. Do you know this principle? First come first serve, right? First come first serve. Sir, the person who is going to come first, he will get service first. Okay, that is it follows first come first serve policy. FCFS. That is it follows first come first serve policy. Next up. If fairness is false, then which waiting thread will get the chance? We can't expect. If a fairness is false, then which waiting thread will get the chance? Which waiting thread will get the chance? Which waiting thread will get the chance? We can't expect. Which waiting thread will get the chance? We can't expect. Which waiting thread will get the chance? We can't expect. Okay, that's all. Are you able to understand, right? So this is what is the re-entrant lock with the fairness policy. Can you tell what is the default value for fairness? What the default value for fairness is false. If we are not setting anything, then by default is the false. We don't know which thread is going to getting the chance. Take a note. The default value for fairness is false. The default value for fairness is false. The default value for fairness is false. Okay. Next, better to take a bit style. Which of the following declarations are equal? 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 Okay. So take that line. Example. Add re-entrant lock L is equal to re-entrant lock L is equal to re-entrant lock L is equal to new re-entrant lock. Re-entrant lock L is equal to new re-entrant lock. Next, re-entrant lock L is equal to new re-entrant lock of true. Re-entrant lock L is equal to new re-entrant lock of true. Next, re-entrant lock L is equal to new re-entrant lock of false. Re-entrant lock L is equal to new re-entrant lock of false. Next, all the above. Next, all the above. Can you tell which two lines are equal? First and third. First one, because the default value is the false. That's why either first one or third one, both are equal, right? Okay, that's all. First and third. Next, keep supporting. Important methods of re-entrant lock. 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 Okay. Sir, here just observe the terminology well. Important methods of re-entrant lock. What the point is, take a bit special care. Entrant lock is the that's why whatever methods by default available in the lock, by default available for the re-entrant lock, correct or not? Because it's the implementation class of interface, then all the interface methods should be implemented by re-entrant lock. That's why these methods are available there. Sir, which methods? How many methods are there in the lock interface? 5 methods: lock, try lock with time, lock interruptably, and unlock. Just take these 5 methods first. Important methods of lock. Take these 5 methods first. Void lock. Next, boolean try lock. Take clearly. I hope is clear for all of you, right? Okay. Now next method, here just observe void lock, try lock of lock, like this one. Now I'm taking here, just observe, I'm taking clearly here see. So int here see the remaining extra methods are not, don't feel only lock interface method, there are some more methods are there. Int get a hold count, int get a hold count, okay, this is. So get a hold count, okay, here how many holds current thread has, are you getting? How many holds current thread has is nothing but like get a hold count. Next boolean is held by current thread, okay sir, either lock hold by the current thread or not, are you getting? So L dot is held by current thread or not, okay, this is. So if I can take like this, now this lock occupied by or hold by current thread or not, like next. So int get a queue length, you know, int get a queue length, how many threads waiting to get the lock, are you getting? So get a queued threads, sir, which threads are in the queue to get the lock, which threads are in the queue to get the lock. Next boolean has queued threads, boolean has queued threads. Can you please check whether queued threads are there or not, are you getting? Queued threads or has queued threads or not. Next boolean is locked, is this lock already locked by some person or not. Next is a fair, boss, is this lock is the fair or not, fairness policy is the set or not, like if fairness policy is the true, then this method is going to return what? True. Are you getting? Next get owner, boss, who is the owner of this lock, currently this lock hold by which person is nothing but like, okay, take the remaining first method, get a hold count, get a hold count, get a hold count, returns number of holes on this lock, returns number of holes on this lock, returns number of holes on this lock by current thread, returns number of holes on this lock by current thread, by current thread, by current thread, returns number of holes on this lock by current thread, okay, like current thread. Next boolean is held by current thread, boolean is held by current thread, is held by current thread, is held by current thread, boolean is held by current thread. Next add, so returns true if and only if, returns true if and only if lock is hold by current thread, returns true if and only if lock is hold by current thread, lock is hold by current thread, returns true if and only if lock is hold by current thread, current thread. Next int get a queue length, int get a queue length, get a queue length, int get queue length, returns number of threads waiting for the lock, 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 waiting for the lock. Next collection get a queued threads, collection get a queued threads, get a queued threads, collection get a queued threads, get queued threads. It returns a collection of threads, it returns a collection of threads, returns a collection of threads which are waiting to get the lock, it returns a collection of threads which are waiting to get the lock, it returns a collection of threads which are waiting to get the lock, which are waiting to get the lock, Next boolean has queued threads, boolean has queued threads, boolean has queued threads, boolean q has queued threads, okay, has queued threads, returns true if any thread waiting to get the lock, returns true if any thread waiting to get the lock, returns true if any thread waiting to get the lock, to get the lock, to get the lock. Next, boolean is locked, boolean is locked, boolean is locked, boolean is locked, returns true if the lock is acquired by, returns true if the lock is acquired by, returns true if the lock is acquired by, acquired by same thread, boolean is locked, returns true if the lock is acquired by some thread, not same, some thread is locked or not, maybe same thread or another thread, lot is locked, like returns true if the lock is acquired by some thread. Next, boolean is fair, boolean is fair, boolean is fair, returns true, returns true if the fairness policy, if the fairness policy is set with true value, returns fairness policy, returns true if the fairness policy is set with true value, returns true if the fairness policy is set with true value. Next, thread get owner, thread get owner, thread get owner, get owner, and returns the thread which acquires the lock, returns the thread which acquires the lock, which acquires the lock. So who is the owner of this lock? Is nothing but thread get owner, returns the thread which acquires the lock, which acquires the lock, which acquires the lock. Okay, so these are various things what you people should aware. Okay, are you getting right? Okay, so these important methods are there. Just first example, let me explain how to use these methods and so on. Second example, how we can replace synchronizer keyword with this re-entrant lock mechanism. Are you getting right? Okay, this is both example so that you can aware. Okay, now just have a look once. Okay, so now just observe. So these are the methods what we covered. Now let me go for a simple example. Okay, how to use a re-entrant lock. Re-entrant lock. Here just how to use a re-entrant lock. Re-entrant lock 2. Here there are multiple examples are there. Just let me. Okay, anyway, just observe re-entrant lock 2. Okay, have you observed what import statement I wrote? java.util.concurrent.locks star is nothing but like I took class re-entrant lock 2 public static void main. Okay, re-entrant lock L is equal to new re-entrant lock. Sir, L dot lock is nothing but like. So can you tell just we created one re-entrant lock. Now L dot lock. This line executed by which thread? Main thread. So main thread hold this lock object. Now so L dot lock once again. So main thread hold. How many holds are there by the main thread? 2 holds. Now system.out.println L dot is locked. What the answer we are going to get? L dot is locked. True. Next, system.out.println L dot is held by current thread. Is held by current thread. Sir, is it held by current thread or not? Who is the current thread? Main thread. That's why true is the answer. Next, system.out.println L dot get a queue length. Is there any other thread waiting for get the lock? No other thread. Here only one thread is available. That's why no other thread is 0. L dot unlock. how many holes main thread has? Actually 2. Whenever I call alert unlock, now how many holes current main thread has? 1. Is it lock will be released or not released? Not released. Now I'm asking L dot get a hold count. Can you tell now how many holes are there? 1. L dot is locked. What the answer we are going to get? Yes, boss. It's locked. True. Next, L dot unlock. L dot unlock. Okay. Next, system dot out dot println. L dot is locked. False. L dot is a fair. Is nothing but false. Are you getting L dot is locked? Okay, false. L dot is a fair. Is nothing but. Is it fair lock or not? False. Because I didn't set any fairness policy. Are you getting? Now just observe. So outputs are true, true, 0, 1, true, false, false. Whether same set of output we are going to get or not, let me cross check. Yeah. Java C Re-entrant log2.java. Okay. Next and after that Java Re-entrant log2. What is the output by default we got? True. Okay. True, true, 0, 1, true, false, false. Is nothing but like way. So can you please cross check? True, true, 0, 1, true, false, false. True, true, 0, 1, true, false, false. Correct or not? Okay, this. Sir, how to use these methods? Is nothing but simple, minimum, important methods we use in this example. Just take this example. Just familiar with the methods of re-entrant lock at this program. And beside every SOP, the corresponding output is also there. So now the next example, second example. So in the place of synchronized keyword, how we can use this lock concept? Are you getting? I don't want to use that bloody synchronizer keyword. I don't want to use synchronized block or synchronizer method. Without that, how I can achieve thread safety? How we can use synchronized, I mean re-entrant lock in the place of synchronized? Just listen. Have you remembered, right, which example we took to explain synchronization in the multithreading? Have you remembered good morning Dhoni or good morning Yuvraj? Like we got some example, right? Same example, let me repeat once again. With the synchronized, without synchronized, I will show. Okay, this is now observe. I hope you people aware, you remember that example, right? Okay, now let me go for that simple example, right? Here I'm taking, legend, I'm taking a simple class display, like one class I'm taking. Listen carefully, class display. This display class contain one method, public void wish method, public void wish method, string name, public void wish method, string name is there. Now my job is for int I is equal to 0. For int I is equal to 0, I is lesser than 10, I plus plus. For int I is equal to 0, I is less than 10, I plus plus. Okay, try. Okay, here just I'm taking system.out.println. Okay, here or otherwise system.out.println good morning. Okay, like this, good morning. Next try. Okay, thread dot sleep off some 2 seconds it's always going to sleep after printing good morning. So do you know system.out.print only, not println, print sleep, catch block, interrupted exception E. Now system.out.println of name, whatever the name is there, like I'm taking, and the end of the for loop, end of the wish method, end of the class. Are you getting? Sir, here if I create a display object, if I call wish method, suppose I'm doing that, legend, display d is equal to new display d dot wish method of Dhoni, like I'm passing, d dot wish method of Dhoni like this I'm passing. Can you tell what is the output we are going to get? Good morning, and then good morning, and then sleep for 2 seconds, and then Durga, and then once again good morning, sleep Durga, good morning, sleep Durga, good morning, sleep Durga, like this cycle by default will be repeated. How many times it is going to be printed? 10 times. Are you able to get? So after printing good morning, waiting for 2 seconds, after that Durga will be printed, and then once again good morning, and then sleeping, and then Durga. Like how many times it will be printed is nothing but 10 times, of course. Not Durga, Dhoni. Maybe I thought that. So like good morning Dhoni, like 10 times it is going to print. Clear, right? But now I don't want to call manually this method. Who is the responsible to call? My thread is the responsible. What I will do here is just observe this one. Sir, this example we took already, not required to keep much explanation. In the synchronization, same example I took. Now class my thread extends a thread. Class my thread extends a thread. Class my thread extends a thread. Okay. Now I'm taking display D, comma string name. Display D, comma string name. Okay. Now my thread of display D, comma string name. Okay. So this dot D is equal to D. this dot name is equal to name. Okay, this dot d is equal to d, this dot name is equal to name. Next here just public void run method. Sir, public void run method. Within the run method, on the display object I am calling which method? Which method? By passing name as the argument. That's all. So if we create this thread object and t dot start, now run method will be called. Run method is going to call on the display object which method like. But here one small twist. Here display object and name you have to pass as the constructor argument. Okay, this is. Now let me take last example. This example is so main class synchronized demo. Class synchronized demo public static void main method string array accept. Public static void main string array accept. Now the target is here, see this one. My thread t1 is equal to new my thread of my thread t1 is equal to new my thread of. But to create my thread object, compulsory display object must be required or not? Display object and string name. String anyway, any name I can pass. But display object, let me create one display object at the beginning. Display d is equal to new display. Display d is equal to new display. My thread t1 is equal to new my thread my thread t1 is equal to new my thread d comma dhoni, like I am taking d comma dhoni. Next my thread t2 is equal to new my thread of d comma Yuvraj, like I am taking d comma Yuvraj. Now t1 dot start method, t2 dot start method, t1 dot start, t2 dot start. Okay, like how many? So can you tell how many threads are here? How many threads are there? 2. Other than main forget about 2 threads are there. For the first and second thread, display object is the same. Are you getting? On the display first thread trying to call which method? Which method? By passing dhoni as the argument. Dhoni. Now first thread starts execution, good morning, and then it is sleeping. Meanwhile, on the same display object, second thread is going to call which method? By passing which one is the argument? By passing Yuvraj as argument. Do you know? Both the threads are going to be executed simultaneously. What output by default you are going to get is what? Mixer output, right? Any explanation is required. Both the threads are going to execute, but the output we are going to get is nothing but mixer output by default. Okay, let me execute this code. You are seeing, sir, irregular output we are going to get. So let me take synchronized demo.java. Sir, all these things I don't want. 1 minute. Sir, class display for int I is equal to 0, I is less than good morning, and then what is nothing but like here, see, sir, for loop catch. Next class my thread extends thread display string name, my thread of display string name constructor, and then run method, right? D dot wish of name display d is equal to, okay, here just observe, display d is equal to new display d 1 gone 2 gone. Okay, my thread t1 is equal to new my thread of d comma dhoni, d comma Yuvraj, t1 dot start, t2 dot start is nothing but like we have. Okay, now observe this one. Okay, so here I didn't use anywhere synchronized keyword. Everything is the same example only. Everything I didn't use synchronized keyword, I didn't use re-entrant lock. What I will do here is Java C synchronized demo, like I'm taking. Okay, value Java synchronized demo is nothing but like, but the output by default we are getting mixer output. Are you getting? Good morning, like mixer output by default we are getting. I hope is clear, right? Mixer output I'm getting, right? Okay, like sir, here what I will do, how we solved this problem is, at a time this wish method should be executed by only one thread. If I can make this guarantee, then automatically what will happen? I can able to get what? Regular output, right? That's why what we did is declare wish method synchronized. Okay, this one we took. Now what is the output by default we are getting is nothing but like good morning. So until Dhoni completion, your thread should be waiting state. So both the threads are going to execute one by one. So the output by default we are going to get what? Regular output, right? Can you please cross check? Good morning Dhoni, like regular output by default we are going to get. Good morning Yuvraj, like. Are you getting the point, right? Okay. Okay, this is so. Now what I will do here is observe. Sir, I don't want to use a synchronizer keyword without declaring wish method as synchronized. I have to run the show with the re-entrant lock. What I will do here is, have you observed? See this one. Sir, class display public void wish method like this. What I will do? Let me create one re-entrant lock. Re-entrant lock L is equal to new re-entrant lock. Are you able to get right? Re-entrant lock L is equal to new re-entrant lock. Now first thread call run method, first thread call wish method. Whenever first thread call wish method, immediately within the wish method first activity L dot lock. First activity is nothing but what I will L dot lock. Now first assume Dhoni thread got the chance. Now Dhoni thread got this lock and continue this one. Meanwhile Yuvraj came. Yuvraj also required the same lock, but Yuvraj thread, so Dhoni thread already occupied this lock. So Yuvraj has to wait until completing Dhoni. That's why Yuvraj in the waiting state. Now Dhoni starts execution. After completing, now L dot unlock. Now Dhoni is going to unlock. Are you getting? If Dhoni is going to unlock, now who is going to getting the chance now? Yuvraj is going to getting the chance. So these lines, whatever there, these lines should be executed by only one thread at a time. Are you getting? So am I going to get regular output or irregular output? Regular output, right? Are you getting? Because so this part should be executed by only one thread at a time. Sir, L dot lock. After completing my safe operation, that's all, unlock. So next waiting thread will get the chance. That's all. What is the need of using that bloody synchronizer keyword? Are you getting? Immediately you may ask, sir, what synchronizer keyword is doing? Same thing only here we are doing. Of course, in this example, in the place of synchronizer I am showing. But in the next example, sir, I don't want to wait to get the lock. If I will have the lock, then okay, well. If I am not having the lock, try lock method. Such type of try lock, extra API support, such type of thing is not there with the traditional synchronizer. Don't feel, sir, equivalent to synchronizer, re-entrant lock concept came. Re-entrant lock concept is more powerful than is nothing but synchronizer keyword. But in this example, in the place of synchronizer, just we are using what is nothing but re-entrant lock concept. Are you getting? So let me execute this code. Sir, here observe, I don't want to use this bloody synchronizer keyword. Okay, now I'm taking, sir, 1 minute, let me take re-entrant lock example only. What is the need of going synchronizer demo program? Here seeing import java.util.concurrent.locks class display re-entrant lock L is equal to new re-entrant lock public void wish method L dot lock. Now save this operation and then at last what? L dot unlock. Class my thread extends a thread display D constructor run method. Here display D, here my thread T1 is equal to new my thread of D comma Dhoni, D comma Yuvraj, D comma Kohli, T1 dot start, T2 dot start, T3 dot start. Like this I am taking, right? Sir, can you tell regular output or irregular output? regular, because this part should be executed by only one thread at a time. Is it clear? Right now see this one. Okay, what is the name of this program? Is Re-entrant lock demo 1. Java C Re-entrant lock demo 1.java. Next Java Re-entrant lock demo 1. Re-entrant lock demo 1, like this I am taking. Are you getting? Good morning Dhoni, good morning Dhoni, like. I hope you people can aware clearly, right? So what is the output by default we are going to get? So make sure you people should have clear clarity, right? Good morning Dhoni, like. So and then good morning Yuvraj, like. I hope is the terminology the clear, right? Now clear for all of you, right? That's all. Like this it's going to be continued, right? Okay, like. So it's a clear for you people. Okay, anyway, take this example, right? Take the example from the screen. This is what how to use traditional synchronizer keyword in the place of synchronizer keyword. How to use a re-entrant lock. So take clearly. completed, right? Just 1 minute. Completed, right? Okay, so just here add one comment. I hope is that clear now. Just better to take this one l dot lock as line 1, l dot lock as line 1. Have you took the program right? L dot lock as line 1, L dot unlock as line 2, L dot unlock as line 2, unlock as line 2, L dot lock as line 1, L dot unlock as line 2. Okay, here just add L dot unlock as line 2, line 1, line 2, like. Okay, add. If we comment line 1 and 2, if we comment line 1 and 2, if we comment line 1 and 2, then the threads will be executed. Then the threads will be executed simultaneously. Then the threads will be executed simultaneously. Be executed simultaneously, and we will get irregular output. Next up, if we are not commenting lines 1 and 2, if we are not commenting lines 1 and 2, if we are not commenting lines 1 and 2, then the threads will be executed. Then the threads will be executed one by one. Then the threads will be executed one by one, and we will get which output, and we will get regular or irregular output, and we will get regular output, regular output like. Okay, sir, this is the example how to use a re-entrant lock in the place of what? Synchronizer keyboard. Okay, now flexibility of re-entrant lock. Here, sir, we can try for lock without waiting, or we can try for lock with some time period waiting. Such type of flexibility also there, but here such type of thing is not there in the case of what? Synchronizer keyboard. Are you getting right? Now next, keep submitting demo program for try lock method. Demo program for try lock method. Demo program for try lock method. For try lock method. Okay, very simple here, legend. If you are not going to understand directly, then I will write on the board so that you can get much clarity. First try, it's a very simple. Here I am taking, sir, class re-entrant lock demo 3. My thread T1 is equal new my thread of first thread. First thread is the name of the thread. Second thread is the name of second thread. T1 dot start and T2 dot start. Just I am starting how many threads? 2 threads. Okay, now here see how this my thread class is implemented. Simple. Class my thread extends a thread. Here I am creating a re-entrant lock, because for this class only I am creating multiple thread object. That's why lock should be unique. So I am taking static. Why I am using the word static? How many copies of static variable will be created? Only one copy. So only one lock. Even multiple threads are there like. Sir, this is the constructor to attach name, to associate name constructor anyway. Sir, public void run method. If L dot try lock. Sir, I am trying to get the lock. If L dot try lock. Assume how many threads are started? First 2 threads. Assume first thread got the lock. If the first thread got the lock, system dot out dot println thread dot current thread dot get name is nothing but first thread got lock and performing safe operations. And after this, my first thread is sleeping for 2 seconds, and then first thread releasing the lock. Okay, whenever first thread got the lock and start executing, second thread came. Second thread also ask if L dot try lock is nothing. Can you tell if the lock is available or not? Not available, right? Because if the lock is already occupied by first thread already start executing this one. So now second thread came, L dot try lock. Is it available or not available? Not available, because already first thread got. If it is not available, now my second thread will wait or will continue its execution. Try lock method won't wait, immediately can continue. Try lock method returns false. Pass lock is not there, returns false. If it is a false, else part is going to execute. Are you getting? Simple, man. Here see, don't get confused. In the last session, try lock method I explained right how the behavior. Try lock method, how it is going to work. First I will check for lock. If lock is available, then immediately I will get. If lock is not available, try lock method simply returns what? False. Here see, if L dot lock, if L dot try lock, because try lock method return type is the boolean. Try lock, okay, like this, else, so like this we have. Now 2 threads are there, T1 and T2. First thread came, L dot try lock. Immediately first thread got lock, because for the first thread lock is already available. First thread got the lock, performing safe operations right. Now second thread came, L dot try lock. Second thread came, L dot try lock. Now the second thread is going to ask, okay, this is, boss, can you please check whether lock is available or not. Now try lock method returns false, because lock is not available. Lock already occupied by T1. If it is not available, returns false. My second thread won't wait, immediately false, right? Continue else part. So performing alternative operations. So one thread will perform safe operation because it has the lock, but second thread will perform alternative operation because this thread is not going to get the lock. Clear for all of you, right? Okay, now observe this one. Can you please cross check, Anna? Don't get confused. Here see, sir, run method will be executed by how many threads? 2 threads, because both the threads are same class threads only. Now first thread came, yeah, if l dot try lock, oh first thread got the lock and continue, right. Meanwhile second thread came, second thread is also asking to get the lock, but that lock is not available, then immediately else part is going to execute, right. Okay, now see this one here, Java C, what is the program na, re-entrant lock demo 3, re-entrant lock demo 3 dot java, yes, okay, demo 3, here see, oh first thread got lock and performing safe operation, second thread unable to get lock and hence performing which operations ana, and hence performing alternative operations, are you getting that, alternative operations like, okay, clear. Now let me go for once again, let me run here, first thread got the lock and performing safe operation, let me run once again. There is no guarantee only first thread is going to get the lock, sometimes second thread may get the lock also, okay, here very few lines of the code, right, that's why we may not expect so much difference in the behavior. Okay, only every time first thread is getting the lock, there is no guarantee compulsory it's always going to get only first thread, sometimes maybe a second thread is also can get the lock, getting. So anyway, in this example only one or two lines, right, that's why if it is a huge output then first thread or maybe second thread also, no guarantee at all. Completed, right? Are you able to understand? So try lock, sorry, if lock is available provide, if lock is not available then I don't want to wait, I will perform alternative operation. Is it possible, Anna, is it possible, this one is no such method, something like it is why no, re-entrant lock demo 1 like I took, right, actually re-entrant lock demo 3 is our program, by mistake it came. Okay, anyway, sir, here what is the, here just observe this one, this type of facility can I expect with the traditional synchronizer keyword? Possible or not possible? Not possible, because if lock is available provide, lock is not available until I will wait, until getting the lock, until getting the lock I will wait. This is the normal traditional synchronizer keyword, but in the re-entrant lock, if lock is not available, no problem, I will have alternative operations, happily I can execute those. Clear for all of you? In this case, if the thread will enter into waiting state or not, never entered into waiting state. Okay, take this example also, if you are getting the doubt anywhere, let me know. Take clearly. Run method completed, right? Next, thread dot current thread dot get name, unable to get lock and hence performing alternative operations like next re-entrant lock demo 3, first thread and the second thread. Completed, I hope. Now compulsory better to take output also. Okay, Java C. What is the name? Re-entrant lock demo 3. Re-entrant lock demo 3. Okay, just take this output. First thread got lock under performing safe operations. First thread got lock and performing safe operations. Second thread unable to get lock and hence performing alternative operations. Second thread unable to get lock and hence performing alternative operations. Alternative operations. Alternative operations. Okay, like completed, right? So this is about the demo program for try lock. Are you getting? Okay, this is. So now try lock with the time period. Okay, just legend this example well. Here take special care. Not that much easy, just see. Here I am taking just T1 dot start, T2 dot start. Sir, same whatever the examples we took, T1 dot start, T2 dot start. First thread, second thread. Now how the run method I am going to implement? Public void run method I am taking. Public void run method I am taking. Now here just make sure my first thread here, the first thread always trying to get the lock. Here do sir, do I am taking, do. Next so here if do while loop I want to take. If here I'm taking 1 minute. If 1 minute, just how we can go for that. Do while break. Yes, here just observe. Do I'm taking. If assume I'm trying to get the lock. L dot try lock. If the lock is available, please give. If the lock is not available, then I will wait up to 5 seconds. Are you getting? If L try lock 5 seconds time and 5000 milliseconds. That's why what I have to take time unit dot what is the value? Milliseconds. time unit dot milliseconds, like I'm taking. If L dot try lock 5000 comma time unit dot milliseconds is nothing but like. Here if I got the lock, are you getting? Because first thread got the lock. System dot out dot println thread dot current thread dot name is nothing but what is the name of the thread? Thread dot current thread dot get name. Okay, dot 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 got lock, dot 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 got lock. Okay, like this person. After getting the lock, what this person is going to do? Try thread dot sleep off 30,000 milliseconds. This person is sleeping. 30,000 milliseconds, 30 seconds. Okay, this person is sleeping. Now system dot out dot println after 30 seconds sleeping, this person is going to wake up and is going to release a lock. Thread dot current thread dot plus dot 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 thread dot current thread dot got releases the lock. Releases lock is nothing but like L dot what is the method? Unlock. L dot unlock method. And because I am in do while loop, right? Now once I got the lock, perform safe operation, and then even I release the lock, then break means what? Come out of do while. If even 5 seconds waiting also, still I didn't get the lock, what I will? Else system dot out dot println SOP of so thread dot current thread dot get name dot 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 unable to get lock, thread dot current thread dot get unable to get lock, and will try again, is nothing but like else part I am taking. Okay, and do while are true I am taking, do while of true. Now observe, take a bit special care understanding this one. Why I am writing on the board instead of explaining directly on the system, you have to get much clearly. Sir, here do while of true, what is this one? Infinite loop. In the then when I will come out, break statement I kept, then I will come out of this do while, run method is going to complete, that's all, my thread is going to dead. Now t1 dot start, t2 dot start. Sir, assume first thread came, first thread got lock and then sleeping. Meanwhile second thread came, second thread trying to get the lock, not available. Then max how much time my second thread can wait? 5 seconds. But this person is sleeping 30,000 milliseconds, is nothing but 30, you won't get the lock. If you won't get the lock after waiting 5 seconds, then immediately false means else. Boss, I am the second thread, I am unable to get the lock, I will try again, is nothing but like this is while loop, right? While of true, once again second thread came, while once again, but still main thread is in, first thread is in sleeping. Now second thread another 5 seconds, but even after first 5 seconds, after 5 seconds you won't get the lock, then boss, I am the second thread, I am unable to get the lock, I will try again, is nothing but like. Do you know this cycle will be repeated until main thread, I mean first thread sleeping completed. If the first thread sleeping completed, immediately first thread releases the lock. Until this person releasing, second thread keep on trying for every 5 seconds. So releases the lock break. So first thread came out. Now whenever this person requested, now the lock is available or not? Yes, I got the lock. Second thread, boss, I am the second thread, I got the lock, I am happy now, I got the lock. After completing, boss, I am releasing the lock, and then L dot unlock break come out. Both threads are going to complete. Are you getting? Here one thread will get the lock in the first attempt only, but a second thread will get the lock after multiple attempts. Until getting the lock, my second thread keep on trying, right? This one is going to be happen. Is it clear for all of you, right? Now observe this one. Now take a bit special care. Sir, here just observe static, same example, re-entrant lock not this one, 1 minute on. Re-entrant lock demo 4.java. Here see, import java.util.concurrent.locks.start. Import java.util.concurrent.locks.start is nothing but like import java.util.concurrent.start. Concurrent.start. Okay, like class my thread extends a thread, just a static re-entrant lock, L is equal to new re-entrant lock, my thread of string. Are you getting? Next the public void run method, do try. So here 5 seconds I'm taking, and then 30,000 milliseconds. Okay, first thread was thread.current thread dot get name got lock, first thread got lock, sleep, and then unlock, and then unlock. So this is releases lock, break, else so thread.current unable to get the lock, try again, next catch block, and while of true, like this I'm taking same example, first thread and second thread. Now let me execute this code. Re-entrant lock demo 4. Here say this one. Yes boss, re-entrant lock demo 4. First thread got lock and it is sleeping. Second thread will wait how many second? Second thread unable to get lock, will try again. Second thread unable to get the lock, will try again. Second thread unable to get the lock, will try again. 5 seconds, 5 seconds, 5 seconds, 30 seconds means is nothing but 6 times. So once the first thread releases the lock, then only second thread will get that lock. Have you observed? First thread releases the lock, second thread got the lock, and then second thread will sleep for 30 seconds, and then second thread releases the lock. That's all have you observed. Just 30 seconds second thread is going to sleep, and after 30 seconds second thread also will release the lock and break. That infinite loop is going to be break. 30 seconds time, half minute oddly. Yes, second thread releases the lock, that's all. Are you able to understand? Right? Try lock with the time period. How to use is nothing but like, sir, I'm keep on trying until particular amount of time. Like take this example, example 4. Completed, right? Take clear. So why concurrent.start? Because we use a time unit. Time unit is available java.util.concurrent package only. completed, right? Okay, better to take output also. Completed up to this. Okay, take the output also. Completed. Okay, so that's all. This is about lock interface and re-entrant lock. So after knowing this concept, usage of synchronizer keyword never recommended. Are you getting that? Okay, this lock concept is more enhanced flexibility to the programmer than synchronizer keyword. But unfortunately, most of the people don't know about this concept. Still, the people are habited with what synchronizer keyword only. Okay, this is so that part anyway. And then that's all. These are the things what you should aware. The more flexibility we are going to get with the try lock, with the time period, without time period, deadlock, such type of terminology not applicable once we are using try lock mechanism. That's why make sure you people should aware this is the more flexible, this is the more enhanced than traditional synchronizer keyword. Okay, that's all.